We are going to jump into some algebra now, and to start us off we're going to go look at Tim and Moby on Brain Pop, just a short little clip of their explanation of algebra really quickly. Take a look.
Dear Tim and Moby, when those letters are all over math problems, I have no idea what to do. From Ned. You're talking about algebra. That's the branch of math where you solve equations with variables. Well, an equation is a comparison of two sets of numbers with an equal sign. Like 2 plus 3 equals 5 is an equation. The quantities on each side of the equal sign have to be, equal. A variable is a placeholder for a number we don't know yet, so instead we use a letter. Whether it's an X, a Y, an A, or some other letter, a variable is just an unknown number. The numbers in an equation are called constants because their value is set. You can think of equations with variables like a fill-in-the-blank question. The purpose of an equation with a variable is to fill in that blank. In other words, find out which number makes each side of the equation equal.
Okay, so now we're going to kind of take a look at this in action. Tim and Moby mentioned a couple of different things that were really important. One, they gave you the definition of this word variable. And if you were looking at these three equations on my examples here, you will see that we have three different variables. And I've just used a shape, so a trapezoid, a triangle, and a rhombus for our three variables. But our variables can really be anything in math. They can be a shape, they could be a blank box, a question mark, or as you move into higher math, you'll use, of course, letters to represent numbers. But basically they're just think of them as a blank that you can solve for. The word variable comes from being able to vary or change depending on what equation you put it in. And so, in our first equation, we could figure out what this trapezoid is worth in a couple of different ways. A lot of you would probably just guess and check, so you could think in your head, something plus 1 will give me 4. And you would know that this trapezoid is equal to 3. So that means anytime I see that trapezoid, I would plug in 3 if it was for an equation such as that. So on the next one for our triangle, hopefully you remember what that dot means in higher level math. It is not a decimal point, it is not down low. That dot represents a multiplication symbol. And the reason we really use that dot now is because of the use of numbers. So if this said 4 times a triangle equals 20, you could use that guess and check. What could I put here? Let's just say, oh, maybe it's 4. Well, 4 times 4 does not equal 20. So the triangle is not equal to 4. We're trying to figure out what the triangle is equal to, what we could plug in for the triangle. That would give us 20. So of course that would mean that our triangle is equal to 5, because 4 times 5 is 20. So off to the side we could say a triangle equals 5 for this equation. Now as you move on in math, you could just imagine that if instead of a triangle there I had an X as my variable, because a lot of times we can use letters as our variable. If I had an X there and then used the time symbol that looks like that, that would be very confusing. So in higher math you see that dot being used for multiplication in an algebra equation, or a lot of times, like we also learned earlier this year, you can just put the number directly next to the variable. And when there is no symbol there, we already know that that means multiplication, just like when we learned about order of operations. So if we wrote our equation like that, x is our variable, and we would say x equals 5. Why? Because I can plug in 5 for x, and 4 times 5 will give me 20. I'm just using that guess and check method still at this point. So I'm going to put our equation back that we started with. Alright, and then jump to the last one. Now, here's the other thing that Tim and Moby mentioned in their video that I really thought was great, and that is a lot of times we get very caught up on our answer always being on this right-hand side and being a single number. But they reminded us that this equal sign is just a balance point for our equation. So that just means that whatever is put over here has to equal what's on this side. And so I wanted to take a look at this last example, and I just flip-flopped what we would think is the answer and put it over there, put our equal symbol here, and then put the rest of the equation here. It doesn't matter which side we write it on. All that matters is that we solve for this variable, this unknown number, in a way that will make it balance out or be equal to 5. So this one is a little trickier to do, the guess and check method. But we're thinking of what number can I divide by 3 and get 5. So knowing your multiplication facts and knowing how they're related to division may help you here. So for example, maybe we would just guess 9. Well, 9 divided by 3 does not give me 5, so 9 can't be it. Maybe I take here groups of 3s, and I think there's 3 and 6. There's 3 groups. Alright, of 3, that only gives me 9, and so I'd have to keep going trying to figure out how many would give me 5 groups, so 10, 11, 12, 13, 14, 15. So I could ultimately find out that our rhombus is equal to 15, and 15 divided by 3 would balance out our equation, which means our rhombus is equal to 15. Or if I wanted to plug in a different, more advanced math symbol, maybe I would say m divided by 3 is equal to 5, and I could say that m is equal to 15. Basically, I'm just saying that whatever I say this variable equals, I could plug it in and make a true statement. The other method for solving these, besides doing what I called guess and check or plug it in method, is to actually do what's called the opposite operation. So in math, if you perform the opposite operation, and just like we learned with fractions, if you do something to the denominator, you have to do it to the numerator, this equal symbol is the same way in math. If you do something over here, you have to also do it on this side. And so if we wanted to solve for these variables in a different way, we could use what's called the opposite operation or the inverse operation. So basically, we want to make this symbol be by itself, this trapezoid, this variable. If it was a letter, we would want that letter to be by itself. Of course, T isn't a good choice there because it looks like a addition sign. If we want this variable to be by itself, we're going to do the opposite of what's being done to it. So this is having plus 1. The opposite would be take away 1, because the opposite of addition is subtraction. That'll actually make this go away, and our trapezoid be by itself. That means, though, that we have to also subtract 1 on this side, because the rules in math, just like with denominators and numerators, is that if you do it to the top, you have to do it to the bottom. With an equal symbol, if you do something to one side, you must do it to the other. So either way, that tells us that a trapezoid is going to be equal to 4 minus 1, which makes the trapezoid equal to 3, which we already knew from our guess and check method, but this is just using that inverse operation to figure it out. So now let's go over here to our triangle. What would be the opposite of multiplying this triangle by 4? We know at this point in the year that the opposite of multiplying is dividing. So we would divide by 4. And that would make this go away. And we would divide by 4 over here. 20 divided by 4 gives you 5. And we had already determined that this triangle is equal to 5. So here's another way of finding that. Down here, if we wanted to use the inverse operation, we want to get this rhombus or this variable by itself. We want to do the opposite of dividing by 3, so we would want to multiply by 3. That makes this go away. The rule is if you do it on this side of the equal symbol, you must do it on this side. And so that tells us that our rhombus is equal to 15. And again, we already knew that by using the guess and check method. Just wanted to show you another way that you could solve for a variable. So the goal today is to just have an understanding of what a variable is. So a variable is just an unknown number. It could be a symbol, it could be an open box, it could be a question mark, it could be a letter, but it's an unknown value. And then of course our other goal is that you can have a little bit of practice actually solving for what the variable is. Now, one other thing I want to do before you take off and practice on your own is sometimes, like in an IXL activity that you will probably do very soon, instead of just solving for the equation all by yourself, sometimes they may tell you what a variable equals. So they may just give you an expression like m plus 4 and ask you what would this be if they tell you m equals 5. Well, if they give you that, all they want you to do is plug in m in this equation. And they might give you more than one. Maybe m minus 1, and we could do a multiplication one, 3m. They may want you to solve that way. So all they're doing is, what are these equaling if you plug in m equals 5 for all these m's? So you would say 5 plus 4 is 9, 5 minus 1 is 4, and then because there's no operation and they're right next to each other, we know that means multiply. So we're doing 3 times 5, 15. It's just another way that you may be asked to kind of work with variables in the beginning here. So hope this video is helpful, and now it is your turn.